Good morning, children. In the previous classes, we have discussed the process like melting, boiling, condensation, freezing, and also we discussed what is melting point and boiling point. Now today we are going to learn what is latent heat and latent heat of fusion, latent heat of vaporization. So you know this activity. So take some ice cubes in a beaker and place on tripod stand with the help of wire gauge and suspend a thermometer, laboratory thermometer into the beaker with the help of rigid stand. Now first note down the temperature of the ice cube. Definitely it is below 0 degrees centigrade. So let us assume minus 5 degrees centigrade. The temperature of ice cube minus 5 degrees centigrade. The laboratory thermometer is calibrated minus 10 degrees centigrade to 110 degrees centigrade. We can measure the temperature of substances from minus 10 degrees to 110 degrees centigrade. Now the temperature of ice cube, suppose minus 5 degrees centigrade. Now start heating. When we start heating, the temperature of the substance, the temperature of the ice slowly increases. So the level of mercury increases from minus 5 degrees centigrade. So when it reaches the 0 degree centigrade, then the level of mercury remains same. It stops rising. Why? Because here the process of melting takes place. Because 0 degree centigrade is the melting point of ice. 0 degree centigrade is the melting point of ice. So at its melting point, the process of melting takes place. That means the ice starts melting into the water. So again completely the ice cube turns into water. Again the level of mercury starts rising. So when it reaches the 100 degree centigrade, again the mercury level stops rising. Why? Because here it is 100 degree centigrade is the boiling point of water. So at this temperature the water starts boiling. So here the temperature again remains same, but we did not stop on heating. We are continuously heating, but the temperature remains same at 100 degree centigrade. So here see, latent means hidden. The word latent means hidden. So when we start on heating, the temperature increases minus 5 degrees centigrade to 0 degrees centigrade. So at 0 degrees centigrade, it stops rising temperature. Means where does this energy is going? We did not stop on heating. We are continuously heating. Where does this heat energy is going? So this heat energy gets hidden into the content of the beaker. So the heat energy at this 0 degree centigrade, so the heat energy that we are giving, that gets into hidden content of the substance. Here the heat energy gets hidden into the content of the beaker. That heat energy is called latent heat. So what is meant by latent heat of fusion? So the amount of heat energy is required. To convert 1 kg of solid into liquid at its melting point and at atmospheric pressure. See, what is meant by, once again see, latent heat of fusion. Latent heat of fusion means it is the amount of heat energy is required to convert 1 kg of solid into liquid state at its melting point and atmospheric pressure. This is called latent heat of fusion. Then what is meant by latent heat of vaporization? The amount of heat energy is required to convert 1 kg of liquid into gaseous, liquid state to gaseous state at its boiling point and at atmospheric pressure is called latent heat of vaporization. Latent heat of vaporization. I think you have clear. So once again, so at 0 degree centigrade, at 100 degree centigrade, why the temperature remains constant? Because the amount of that is called latent heat. So by absorbing that latent heat, the force of attraction between the particles is breakdowns and gets converted into the next state, like solid to liquid or liquid to gaseous state. Now let us draw a rough graph. I think you know how to draw a line graph. So now I am taking the time and temperature. I am taking time on x-axis and y-axis I am taking temperature on y-axis. So time, just I am draw a rough graph. So initially for this experiment, what is the initial temperature? At 0 seconds, what is the initial temperature? 5. For example, it is 5 degree, minus 5 degree centigrade here at 0 seconds. So we are continuously heating, then the temperature increases to 0 degrees centigrade. It is 0 degree centigrade. When it reaches the 0 degree centigrade, we are continuously heating, but the temperature does not rise. It remains same. So after some time, again it reaches, when it reaches the 100 degree centigrade, it keeps on rising. The temperature keeps on rising. When it reaches the 100 degree centigrade, it stops rising temperature. When it reaches the 100 degree centigrade, so here it remains constant. The temperature remains constant for some time. Again it starts rising. Okay, this is the rough graph for this experiment. See here, it is the 0 degree centigrade. At 0 degree centigrade, what is the state of ice here? What is the state of substance? So here at this time 0 degree centigrade. Here what is the state? Ice, solid state. Here just starting to convert liquid state into water. Here solid state. Here, what is the temperature at this point of time? What is the temperature at this point of time? After some time, the temperature here also 0 degree centigrade. But here, what is the state of substance? Exactly here, state of substance is water. That means liquid state. That means liquid state. So, if I ask question, what is the state of water at 0 degree centigrade? What is the state of water at 0 degree centigrade? It may be solid or it may be liquid. If it is below 0 degree centigrade, it definitely is solid state. If it is above 0 degree centigrade, it is liquid state. At 0 degree centigrade, what is the state of ice? It may be solid or it may be liquid. But I want to ask a question. So, which has more energy? Is ice or water? Which has more energy at 0 degree centigrade? So, water has more energy at 0 degree centigrade. Why? Because here they maintain the same temperature, 0 degrees. But here we did not stop on heating. We are continuously providing heat energy. That heat energy gets hidden into the substance. So here heat energy absorbed by the particles. So the liquid state has more energy than solid state at 0 degree centigrade. So here also, here at this point of time, At this point of time, what is the temperature? 100 degrees centigrade. Here temperature is 100 degrees centigrade. So here what is the state of water? Liquid. So at this point of time, what is the temperature here? Here also 100 degrees centigrade. But what is the state of substance here? What is the state of substance here? Gas. Gas. So what is the state of water at 100 degrees centigrade? What is the state of water at 100 degrees centigrade? It may be liquid or gas. Okay, but which has more energy? Is water or steam? So here gaseous state. What is the gaseous form of water? Steam. Which has more energy? Definitely steam. Why? Because here we did not stop on heating. Even though the substance maintain the same temperature, that we are providing the external heat energy that is consumed by the particles. It gets hidden into the substance. So that is why the gaseous form of water has more temperature as compared to the 100 degrees at liquid state. Okay, thank you.